Good evening, everyone.
Evening. We'll probably wait like until 8:33 and then we'll get started. Make sure anyone who hasn't joined yet get a chance to do so.
Okay. Hello, Jessica.
Hi, Mr. Morgan. How's it going?
Mr. Who?
Mr. Morgan.
My name Dad. Glad everyone could make it this evening. Making sure I recognize everybody without their mask on. Everybody looks different. Happy. Happy.
Okay, there we go. We've reached 8:33. So let us get started. First of all, I would like to thank everyone for joining our special speaker event today. My name is Han Chi.
And my name is Zach. Before we begin, I'd like to first explain how this event is structured. This event is an AMA, or Ask Me Anything, meaning that throughout the next hour, we'll be asking our guest, Miss Morgan, a variety of questions, and you are highly encouraged to join in asking questions. While a lot of the questions will be about her career and specialty in simulation modeling, the questions could otherwise be very broad. For example, careers in computer science, analytics, and government consulting. In order to ask a question, please send your question in the chat. Since this event will be recorded and published, we are happy to ask your question for you. If you are comfortable with being recorded, you may specify that in your message by adding an asterisk, and we will be able to unmute you and you can ask your question yourself.
Awesome. And then my name's Audrey, so I'm just going to give a quick introduction of Miss Morgan. So Miss Jessica Morgan is an Operations Research Analyst at LMI and supports NASA, the Office of the Chief Human Capital Officer, where she works in strategic workforce planning. She received her bachelor's in mathematics from the University of North Carolina at Charlotte and her master's in applied mathematics from North Carolina Agricultural and Technical State University. She has previous experience in government consulting at the Headquarters Department of the Army and Department of State, as well as teaching at NC, A&T, and Elon University. So that was a really quick introduction. So go ahead, take it away, Hanshi.
All right, Ms. Morgan. So are you ready for your first question?
Yes, sure.
All right, great. So we had a quick snippet with the introduction, but can you just expand and describe more on the subject of the work that you are currently doing? And after that, I've got a tiny little follow-up question.
Sure. So as Audrey explained, so I support NASA OCHCO, which is, if you want to think of it like the human resources part of NASA. And so what I do for them is I do analytics for strategic workforce planning. So essentially what we're looking at is the type of people that have been hired in the past, doing analytics on that and predicting what is a good way to move ahead in the future. So if we should continue to kind of hire the same people, or if we should make changes and hire different people, looking into all kinds of things like their attributes, their retirement dates, their demographics, things like that, where they work, where they live, and how all of that plays into supporting the overall NASA mission. So keeping in mind that a lot of things are going to change as, you know, time goes along. So we're in a different time now. COVID has happened. A lot of people are making decisions based on kind of the environment that we live in now. People are deciding to stay and work longer because they can work from home, things like that. So all of that's being taken into consideration when we do this simulation modeling to figure out what's the best advice that we can give the senior leaders to support NASA and make sure that they have the best workforce possible.
Cool. Well, that does sound interesting. It's almost like, I guess you're like an advisor, or you're like a missions officer, almost like for NASA. Is that right?
Yes.
All right. So in previous exchanges, you talked that the work that you do with the modeling, it isn't what you would specifically call like machine learning or AI, like in normal sense. So how would you like define the tools that you're using?
So it's similar. So we are using historical data to make inferences and to predict what's going to happen in the future. There isn't a specific like training process, like the model isn't necessarily learning as it goes to predict things that will happen in the future. It's more so using the historical data that's in there. So basically, we're using the historical data, but that's all that we have to go off of. And so it's an agent-based simulation model though. So what that means is basically in the model that I'm working with, agents are considered employees. And so what you can do with the model, it's a very flexible model. You can make the employees react off of one another, or of course you can code specific things like you know, when they'll retire or when they will separate, like if they decide to leave NASA at a certain time, all kinds of different things. And that's kind of what agent-based modeling is focused towards. It's basically to make a very complex situation kind of more tangible and be able to look at the results that are coming out of it, and again, make decisions based on that. So that's kind of the difference. It's similar, but there's not so much of that training aspect incorporated into the specific model that I'm working with right now.
That makes sense.
Thank you. Could you please tell us like some more specifics about any like research projects you're currently working on? And also, like, do you typically work in like a collaborative environment, or would you say that it's more on your own?
So right now, this is, so I've supported different contracts at different companies, as well as the one that I'm at right now. So previously I was working for Department of State, but at this NASA contract, my specific and sole focus is this simulation model that I'm building from the ground up. So I've been working on this since about last September-ish. So, I mean, if you can imagine, you know, somebody has an idea of where they want to go, but there's literally nothing that they've done yet. So the building process of that, the planning process, the talking with the client, talking with people who are interested in using this for their everyday type of work, planning out how to code this information, because it's easy to, you know, talk back and forth about what's going on, but planning out how to code it and make it make sense, debugging it, testing it, all of those things. It's a very long process. So right now, you know, even with working on it since September, we're still in the kind of initial phase of having a baseline model, which we're kind of marketing to the client and the people that are interested in it to see if this is something that is useful for them? And if not, what feedback can they give us to, kind of tweak it, make it more specific, make it more realistic? So for the first part of your question, the modeling is my sole purpose right now, with my support to NASA. So there's about on the analytics side of human resources at NASA, there's about 6 or 7 of us that support from the LMI side. We come together for like a weekly meeting to collaborate, let everybody know what everyone's doing, but we do work on different projects. I'm the only one working on this specifically. But it kind of just depends. It depends on the contract. It depends on the team that you're coming into. I've worked with some people who have experience in the model that I work with is called NetLogo. I've worked with some people for NASA who have specifically worked on that before. And so it's always collaborative. It's just in different ways. So, like the coding and things like that, I'm kind of taking that on my own. But the idea and the process of building everything, getting feedback, that's definitely a collaborative process. And I'm located in North Carolina. People that work for NASA are separated by centers. So they're kind of all over the country. So, there's people that are in Alabama, Florida, New York, and mostly East Coast. But we all work remotely and kind of collaborate that way. And we're all kind of learning it, along the way, because that was a big adjustment a couple of years ago. But luckily NASA was kind of already on top of it. They're very, very advanced, especially, with collaboration and things like that on, on the computer, so.
All right, we've got a few questions from the chat. So do you have any tips or recommendations for students interested in pursuing academic studies in like AI, statistical analysis and modeling?
So I would say if you are interested in those fields, use the time that, you have available to you right now to anytime that you can. If you know somebody that's in the field, or if you don't, try to network and find somebody that's in the field and see if that's something that you can, what they're doing day to day. If you can, see if you can shadow what they do and see if that's something that interests you, because there's so many different, even being interested, in artificial intelligence, statistical analysis, modeling. There's so many different things that you can do with that. I'm on the government consulting side of things, but I mean, you can do the same things in like the sports world. You can do the same things in more of a like private sector type job. You can do the same things in banking. There's so many different ways that you can go with it, which is a great thing. But I think it's important to kind of have a vision for which direction you want to go in. I would definitely say, analytics is such an evolving field that there's always new things to learn. There's always new things to be on top of, which in some senses could be, I guess, a little intimidating, but it's also great because there's so much that you can kind of pick up on and be interested in and use to your advantage when you're looking for positions and things like that. So, and a lot of this stuff is accessible to you, just literally on like YouTube or things like that. So I would say, first thing, like I said, make sure that you get some type of experience with maybe like shadowing somebody that's in a field that you're interested in. And also just try to stay on top of whatever the new thing is. Because you can even like being in high school right now, you could look up job descriptions and you can see exactly what people are looking for. and kind of tailor your skills to fit that and see if that's something that even interests you. But that kind of gives you a step ahead and a foot in the door to figure out what direction you want to go in.
That's definitely true. Wow. So with this advice, can you tell us a bit more about how you personally learned about data analysis?
So are you talking about like the position I'm in, or just in general, like data analysis in general?
Yeah, just in general, how you got into the field.
So, as mentioned before, you know, I went to school, majored in math for undergrad, and then applied math for graduate school. Initially, before I moved back to North Carolina, I was here, didn't really know like what all the opportunities were. So I did teach, which I really love teaching. I taught college for a year, and then I kind of figured out that I wanted to go more into like the workforce side of things and see how that experience would be. And so I transitioned up to the DMV area because there are a lot of opportunities in this field in the Northern Virginia, like DC area. And that's when I got into operations research. So a lot of the jobs that I've done, so the previous company that I worked for, I supported the Department of the Army. I was in equipping for the Army. So basically doing data analysis to figure out, for instance, how many trucks that they need or how many aircraft that they need for the Army for specific missions. So it was relatively similar. Instead of working on the human side of things, I was working on the equipment side of things. And I did that for a while. That's when I kind of really got into the data analysis and how it affects the real world that we live in. And, kind of figuring out or realizing the data analysis that I was doing affects, the Army and the decisions that they make. And it makes a big difference. So that was kind of my first introduction to the workforce, I would say. That's when I really got interested in the work that I'm doing and kept kind of going at that. As I mentioned, after that, that's when I transitioned companies and I worked as a consultant for Department of State. So that work was a little bit different. So what I did there was I worked on doing analysis on their awards program. So for government, they have a kind of different recognition program, I would say, than like a public or a private job. And so basically they were trying to figure out, are we giving the awards to the right people? What type of people are getting awards? Is it like executives or is it, other employees? How often are they getting them? These awards were associated with money. So how much money are these people getting? Do they feel valued based on the awards that they're getting? That's the kind of work that I was doing for Department of State. And then I switched over to kind of like human resources, data analytics. So I've done kind of all kinds of different projects. And that's also the good thing about government consulting. So with LMI, I mean, it's your choice if you want to stay on the same project. So I could stay with NASA as long as I want to, depending on if we still have that contract with them. But let's say that I've, been on the NASA contract for a while and I'm like, oh, I want to kind of try something different. We have a bunch of different contracts. And so I can look through our internal kind of job data system and see if there's something else that interests me. And you can do different projects and still stay with the same company, still build that rapport with the people that you work with and still advance within that company. So it gives you the ability to try different things, but also kind of perfect your craft and learn different things along the way. So that's kind of my experience and how I got into what I do and how I progressed along the way.
You told us how you got interested in this field and many different research projects that you've been a part of. Do you mind showing us maybe a demo or like some work that you're currently working on, or explain a little bit more about that?
Yeah, sure. So I have a couple of things pulled up. And I saw that there was another question that said, does the model you work with tell NASA how many people to hire? So I can answer that question as I kind of show you guys this. So first I'm gonna go to this is just kind of like a pre-processing. Can you all see this? Okay. This is kind of just like a pre-processing piece of code in Jupyter Notebook using Python. So basically, like for the model that I work with, they'll give me a large data set with a bunch of different variables, and you'll kind of see this in a second. So this is just a pre-processing part of it, because a lot of the data set is in like it's in words, and it's more, you know, kind of complicated than I want it to be. For NetLogo specifically, it's easier to pull in data that's all numerical. And so this is why I have this here. So anyways, they'll give me the data file, I'll read it in. And I'm assuming that you all are fairly familiar with Python and Jupyter Notebook, but I just prefer using Jupyter Notebook because you can kind of like see what you're doing along the way. So that makes it pretty cool. So I'll pull in the data file, and this is what the data file is. This is all, most of the people at NASA, some of their attributes. So if they're full-time or part-time, when they got their last promotion, how many years they've worked, their gender, time in their grade. So grade is, if you're not familiar with that, that's basically like what level of work you're in. So you're assigned a number. So you might be like, they call it GS, like 7 or 9 or 10, and that's just that's what grade means. So you have all of these different attributes. So I just pulled those in, and I'm just doing some data manipulation. So like, for example, here, this is very, very simple code, but NASA has different mission support enterprise organizations. And so that's what all of these are here that are listed. I work for OCHCO here, but we have all kinds of other ones that are also listed here. And I'm just assigning them a number. So you see this 4-letter code in here, return a 1. So, and again, for NetLogo, that makes it easier for it to pull in the data. It'll pull it in faster, and I already have a key that I can go back and reference if needed. And so basically for some of these variables, I'm just taking whatever they have already in the data set, assigning it to a value, and then I assign it a new variable name. I'm gonna like drop some variables I don't need, things like that. So this is, again, just some pre-processing. I can check along the way. You know, I named it data file, so I can type data file in, see if it's doing what I'm asking it to do along the way, which is pretty nice. Like, for example, this is trans_MSCO code. So everything that was in the MSCO column, it just changed to a number down here. I did the same thing with center. NASA has a bunch of different centers, did the same thing for that. Did the same thing so I can bin employees based on whether they're full-time or they're part-time. And that's a big component of the work that I'm doing. So NASA has term employees where you can be hired and have a contract. So you only work there for 2, 4, or 6 years. This is different from me working for NASA as a contractor. They also hire their own civil servant term employees, and they can only work for them for a certain amount of time. And I'll get into that a little bit later. But anyways, just doing continuing to like change things over to numerical values. And then I can drop all of the originals that I don't need anymore, along with some other things that I might not need to pull into the model. And then I export it as a CSV. And so that's, again, pretty straightforward, but that's just like quick data manipulation that I can do in Python instead of, going in Excel and changing things over, because that takes way too long. So I'll do that. After that, I have the file that I want to pull into the model. And so I can also show you guys the model. Let me see. Okay. So this is NetLogo. And all of this that you see like on the screen right now is like stuff that I built. So if you were to just open up a regular like NetLogo model, it would just have like this black big box, and that would be it. The nice thing about NetLogo is that you can add, whatever you want onto the interface. Anything that, and the interface, is mostly just for the user of the model. Like, what makes it easier for them? What are they going to need to be able to run this model? And so here you can like put your own overlay or anything on here. If I just hit setup, these are all the mission support enterprise organizations. So I have them banned into these, little boxes. And then I have the counts of whether they're permanent employees or term employees. These are just little monitors that you can like take a look at as the model's running. Generally, we're not focused on this too much. The model does have a way to output like the results, and that's what I look at and analyze. But I mean, this is like nice to look at for like a little quick, view of what's going on. This here is all of the agents. So when I was talking about agents, they are your employees, and you can make them different like shapes and things like that. Like you can make them a human shape. You can make them into like a bunch of different things, but I just have them as arrows because we're not too concerned about like looking at that right now, but I just want to have that on the side for a reference. So the big thing that we're interested in, I showed you the data file. So it pulled in all of those people, which is 4,600 employees. And here it shows the permanent to total workforce ratio, which is 95%, about 95%. The whole point of this, or what we're looking at initially, is NASA wants to reduce their permanent to total workforce ratio. So they want to have less permanent employees. And we want to see, what effect will that have? If we have less permanent employees, who are we going to have to get rid of? When will we have to get rid of them? How many term employees do we have to hire, and when do we have to hire them in? So those are the type of questions that we're looking at and trying to figure out how long it would take us to do that and how much it would cost to do that. So, and all of this has, code running in the background, but a few of the things that you can change are like, what target ratio are we trying to get to? I said 90%, but I have it set to 70% here. This is another, and they're all sliders. So this is a slider of like, if a person leaves, what's the ratio of the backfill that we're gonna do? Are we backfilling them 1 for 1, 2 for 3, whatever? And then this is the term separation rate. So if you are a term employee, what's the percentage that you'll separate? And so that's kind of the setup of the model. Here you can like run the model forever. You'll start to see these numbers fluctuating because it's working to get this permanent to total workforce ratio down to 70, which is where I have it set. And you can see over here, there's a bunch of like graphs you can add. You can really add anything here. The graphs are not the best. So in most cases, I would like take the data out, export it to maybe like R or something that looks a little better, maybe Tableau, and do it that way. But it shows the permanent to total workforce ratios by by MSEO. And then because it's 1-for-1, this is just a line of separate employees to hired employees on top of each other. So anyways, it would work until it hits 70 and then it would stop. So I'm just going to stop this, but you also have the ability to pull out the data set of what happened at the end of the run and throughout the whole run, and then analyze that so people can ask questions about, what does this all mean? Like, how long is it going to take? How much money is it going to cost me? So yeah, that's the model. And then, like I said, NetLogo has its own language. So this is probably not exactly similar to things you all have seen before. It's not that intuitive, I would say, but it has its own language, and all of this is running in the background to tell the model what to do. So like, for instance, real quick, I'll just go through like this procedure right here. This is telling people, it's telling the model whether to get rid of a person or not. So I have these random values, which I use as comparisons. So if an employee is a permanent employee, that's what 0 means in this case. And if the model draws a number and it's less than the loss rate, then I'm telling it to do these certain things. So I want you to add a counter to the number of separated employees. And I have a permanent separated employees too. So these are just counters, but this also tells you, I have another random number. So if it's less than the backfill rate, which is telling you whether you want to hire another employee or not hire another employee, then, and again, this is kind of a weird coding language, but hatch means make a copy of that employee. So make one copy of that employee, set their time in the grade to 0 because they're going to be a new hire. So they shouldn't have any time yet. Make a counter that there's another hired employee. This is kind of a function within a function. So I'm not going to really go too much into that, but this sets what kind of employee they're going to be, whether they're going to be permanent or a term. And this is just another counter that I had. And then again, weird language here, but die means get rid of the original, the original employee. NetLogo language, I didn't make that up. But anyways, there's a bunch of code running in the background that makes all of this stuff happen. And so that's why I was saying, we have to sit down and kind of collaborate, figure out what we want to do, figure out how that turns into code, and test it to make sure that these things are working appropriately. So that was kind of like an overview of what's been built so far. This is a few versions back, so we've made some changes, but this is kind of what I do on a day-to-day for the modeling part of it.
Very interesting, thank you. We got a couple questions in the chat, but first, can you explain like the financial rationale for why NASA prefers to have more term employees as opposed to permanent employees?
Yes, so this was a big question that I didn't really understand when I came on, and I wanted to get some more insight. So their reasoning for that, so if you think about it, people love to work for NASA. First of all, they love to work there. They work there for a long time. Apparently there's somebody that still works there that's like 90 or something. So they love to work there. So if they bring on a full-time employee, they expect to have that employee for 40, 50 years, maybe, let's just say. For a term employee, if they bring a term employee on, their contract is 2 years, 4 years, or 6 years. If you think about it, every year, just for any job, if you have a full-time employee, you're probably going to give them a bonus within a year or after a year or something. You have to apply inflation to their salary because inflation, versus a term employee. Let's say they're on a 2-year contract. You're probably not going to give them a bonus because they're leaving in 2 years. You might have to apply inflation maybe one time. And so they're rehiring new people every 2 years, every 4 years, starting them at that same base salary, maybe a little bit higher. So it's saving them money essentially, versus this full-time employee that they have for 40, 50 years. They're having to give them more money each year. And it just costs more. And that's not to say, you know, like they don't appreciate their employees or anything like that and don't want to pay them. It's just business. It's a smart way to save money, really. So, and also a huge portion of NASA's workforce are consultants like me. And so I'm quite sure that they pay their employees well, but they're strategic with how they do work and who does work for them so that they can allocate their money as they would like to. So I think that's the big thing.
All right, that's actually really insightful. We've got 2 questions in the chat. So one of them's a bit faster. I heard a bunch of the things you worked on, like classified, right? So the data you showed us just now, like real employees?
So no, well, some of it's real, some of it is not. So that's kind of like filtered data. That's, you know, I can show. A lot of stuff for NASA is publicly available, but of course, a lot of that information is PII and can't, like, you know, be shared. So
True. So we've got a second question here. So Chad C asked that how is the occupation of HR influenced by the technologies that you've just demonstrated, and how the modern data analysis technologies change HR?
Okay, so how is the occupation of HR influenced by the technology? So like I said, you know, it takes a while. It takes a while for a couple of reasons. People like strategic workforce planners who have been doing their jobs a certain way for a long time. Sometimes it's a little hard for them to see the value or just really trust, you know, simulation modeling, because it's subjective, right? It's not going to be completely right. It's just something to kind of lend you advice and say, you know, and give you what if scenarios that you can apply to whatever you're trying to work towards. So it takes some time, but once we have the person who sees the value in it and knows that, okay, I can use this and kind of use it to inform what I'm doing. So for instance, run the model, see in 4 or 5 years, this is the number of people that we'll have, this is the number of people that will have retired, that we may have hired on. You can kind of plan out, because they're already making plans for, like, who will we need in the next few years, for example, to meet these specific missions and make sure that we can build these things and keep advancing and things like that. So they're already making those plans, but this is just something in addition to that, to one, kind of make them think of things they may not have thought of before, that, I don't know, you may not have thought of that idea, but you see something that comes out of this simulation model and you're like, oh, that's something I never thought of. Maybe I should explore that. Maybe I should see where that would take us. So that's one thing. And then I think, again, like I said before, it just gives them an opportunity to come up with what if scenarios. And there's, there's no consequence of, for instance, in the simulation, getting rid of X amount of people and seeing what that will do and how that will change the budget and things like that. That doesn't necessarily mean that you're going to do that in real life, but it gives you the opportunity to explore it. So I think that's the big benefit of how it influences HR and the people that work for HR. And then the second question, how has modern data analysis technologies changed HR? I think kind of like tying back to what I just mentioned, I think it just gives a bigger view. You know what I mean? Like, there's only so much you can know if you don't know. So simulation modeling, because you can answer all of these what if questions and figure things out as you go, I think that gives them the ability to just keep evolving and try to be as best at what they do as they can. And I think to do that, as many, tools and models that you can use, in addition to, subject matter experts, these conversations, experience, and things like that. I feel like all of that kind of comes together to help them, figure out the best way to move forward.
Oh, thank you for the explanation. Yeah, in a lot of fields, right? Like, I guess new technology coming around and people have difficulties accepting it and moving on. So let's see if we have any more questions here. So just, you mentioned that basically these models are allowing you to explore like hypotheticals of how things would turn out if things are done a certain way versus another way. So I'm wondering if that's only in like the current consulting work that you're doing with NASA, or is that like different from what you're doing previously with the State Department and the military?
Yeah, so I will say from the experience that I've had so far, again, NASA is probably, and for a good reason, the most technologically advanced, has people who work in HR but know analytics, and that's not always very common. Know it enough to know that they need someone to support them in that capability. For Department of State, I'm not sure if you all are familiar with it too much, but I did a lot of programming in SAS, which is, like statistical programming. And for Department of State, it was more just like on the data analysis side of like looking at their, like I said, looking at their awards program and seeing, basically, is it fair or not? Well, not coming up with the actual answer, but providing them with the information and kind of collecting that information and giving them my opinion on what I see. So that was more of like just data manipulation, I would say. Same thing with the Army. So I did a lot of work in SAS for them as well. I did a lot of like trend analysis type work, a lot of analyzing the validity of their sources and how they collect their information. Because surprisingly, not everybody is, up to date on the way that they should be collecting things. There's a lot of companies, a lot of government, a lot of government entities that have been doing things the same way for a long time, doing, writing things down or have things in a different data system that just isn't efficient. And so a lot of the work that we do too is kind of like bringing people up to speed on things. So a lot of the contracts that I supported in the past were relatively straightforward data analysis or trying to organize data that they already had, versus what I do now. I mean, everything isn't, perfect there with their data analysis and things like that, but they're at the point where they have the ability to build things and try to answer new questions and do things like that, because kind of the data analysis side of it, or, collecting data, doing more straightforward tasks have already been handled. So it really just depends on, and that's not to say like the other contracts weren't, good or productive or anything like that, but it just depends kind of where you land and what support that they're asking for.
Cool. All right. We have maybe two questions and then we'll be closing. So second to last question, actually. So you worked with a lot of organizations, right? And for quite a number of years. So I'm wondering if you have any like funny stories or particular interesting tales that you could share.
Funny stories. I will say, so when I supported the Department of the Army, I don't know, it's a funny story, but it's very interesting because I worked in the Pentagon. And I think, that was a very like unique experience to have. And so with the job at the Pentagon, and most of the jobs that I've had, you have to have a security clearance to work those jobs. And so like the jobs at the Pentagon, it's like a kind of a vaulted work area. So like you have to leave your phone outside, leave your Apple Watch outside. So you can't bring any electronics in there. It's just kind of like going back into like, I don't know, the Stone Ages. I've always had a phone. So that was interesting. And it's interesting to also see, like how people kind of work together and just communicate and act a little bit differently when there's not as much like distraction or technology involved. So that was definitely a good experience when I went to like the exact opposite. And again, the pandemic happened, but I went to the exact opposite of working at Department of State when you can have your phone on you at all times, and that's not like a big deal. But yeah, I don't know about, I guess, funny experiences, but I've like definitely had experience of working at a lot of different places I never thought I would work, and just working with a lot of different people, working with people that when I supported the Army, obviously a lot of people that I worked with were in the service. So that was a different experience, a lot of uniformed people, and that was very interesting. And then since I've been at NASA, we've all been remote. I mean, so NASA headquarters is in DC, like in local DC or proper DC. And so we've met up like a few times, but it's interesting. It's just interesting working with all different types of people and having being able to sometimes, the thing I appreciate about NASA is just having the opportunity to just have casual conversations. It's not always about work. People there and really enjoy their jobs, and we have a fun time together. So it's good to kind of not it always just be like work, work, work. And so that's pretty nice.
Awesome. It seems like working as a consultant has really allowed you to see a bunch of interesting things and learn from a variety of experiences. So as for our closing question, where do you see modeling and statistical analysis in 10 years? And what excites you most about the future of modeling and statistical analysis?
So in 10 years, I mean, so many cool things have happened over just my lifespan that I never thought would happen. Like, I don't know, I like my car can drive itself and things like that. That's cool to me. And just everything that like I said, is evolving, all of these super cool things that like keep coming up, and there's so much to learn. So I think in 10 years, I definitely think things will have changed a lot. But I think that the exciting thing about like data is that there's always all of these new ideas and new ways of doing things. So I think in 10 years, that will still be the case. It will just be so different. I think the way that we will be working will be a lot different. There's a lot more opportunity to just do so many different things wherever you are. And I think that's what excites me the most, because for me personally, I know, we've been talking about like work, 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 but a lot of the most important thing for me is trying to have like a good balance. And even though I work a lot and I enjoy the work that I do, I also enjoy the fact that I can work remotely, essentially wherever I want to work, and be able to, still do the things that I care about and have a good balance with the things that I do. So I think as far as like data analysis and the things that excites me the most for the future is just seeing where it's going to go and seeing where I'm going to go within it, because there's, again, so much opportunity, so many different things that you can do. And I don't think that I'll ever like just be doing the same thing forever, because even if I decide to stay in data analytics and make that my career for the long term, I have so many different ways that I can go. And I think that's what excites me about it the most.